Hello everyone, my name is Priya Garg and I am going to present a research paper on comparative study of feature reduction techniques in software change prediction. SCP is a branch of research that predicts change-prone classes prior to the software release using various machine learning and statistical models. Various studies in SCP use a combination of different matrix suite, which include object-oriented matrix, graph-based matrix, etc. Due to the increase in number of features, the complexity of data increases, which further encourage researchers to use feature reduction techniques. Looking back at these needs, we have proposed a comparative study that compares and analyzes metrics and feature reduction techniques, which has not been proposed earlier in the field of SCP. In this study, 11 feature reduction techniques have been compared and come under 5 different categories, that is, filter-based techniques that ranks the feature and select top ones, meta-heuristic techniques that use bias-inspired techniques for feature reduction, extraction-based where the original data is converted to another form that retains the best feature combination, wrapper-based that tests for all feature combinations and then selects the best one, and the last, that is neural network-based feature reduction. The performance of these techniques have been compared on 6 datasets that are collected using SourceForge and GitHub. 2 consecutive versions are selected for each project where changes from next version compared to previous versions are recorded. 60 object-oriented and 26 graph-based metrics are combined using proprietary tool Understand and publicly available dataset. These datasets vary in terms of percentage of imbalanced classes from 1 to 76%. This is the experimental setup used for this study, where first the data is collected, followed by application of SMORE for handling class imbalance with a ratio of 0.6. After this, the feature reduction techniques are applied, along with a case where data is directly passed without feature reduction to assess the importance of these techniques. After the application of FR techniques, 3 standard classifiers, that is D-tree, naive-Bayes, and SVM are applied. These classification techniques have been selected based on the vast difference in the baseline algorithm for prediction. In this study, tenfold cross-validation has been used for assessing and validating the results on AUC-RC values, followed by statistical tests which include Friedman and double-Scotland tests. To test the significance of using feature reduction, 12 sets of experiments are conducted consisting of 11 feature reduction techniques and an experiment without using any FR technique. We analyzed the experiments in terms of AUC-RC over the 3 classifiers. The results from statistical validation using Friedman test and double-Scotland test are shown here. And for every classifier, scenario of not using any FR technique always falls in the cluster of the worst techniques which have the lowest ranks. In this RQ, we compare the performance of 11 FR techniques and study the effect of different classifiers on the performance of these techniques. These plots show the results of the Friedman and double-Scotland test for these 3 classifiers. LDA and Wrapper have performed very efficiently, while PSO and CS have performed worst overall. At least 2 meta-heuristic techniques always lie in the same cluster, indicating the similar performance. The average ranking of various techniques like autoencoder, ABC, Firefly, etc. differ according to the classifier, which shows that classifiers affect the choice of FR techniques. In this RQ, we try to find an effective matrix suite for SCP studies. 48 unique feature rankings are generated using 8 FR techniques and 6 datasets, and using them we conducted Scotland tests to form 3 priority clusters of features. 38 of 60 O metrics and 15 of 26 graph-based metrics belong to the first clusters and are frequently shortlisted by these FS techniques. However, the other metrics making up cluster 2 are not necessarily irrelevant but may be conveying redundant information. This study concluded that feature reduction techniques are important for software change prediction. The comparative study with 11 feature reduction techniques indicate the superiority of some techniques over others and also find out the top feature which are selected by various techniques. It was also concluded that the classifiers used affect the performance of FR techniques as well. Thank you.